Hello, everyone. Good to have everyone here. So today is a MongoDB Tech Day, and there are going to be a lot of good talks and exciting ones. Mine is first. I don't know if it's because it's the most exciting or not, but I hope you're going to enjoy it. And I'm going to share today my perspective on providing MongoDB as a service. Okay, so quickly about me. I'm a group product manager at Percona. What I'm responsible for is for our cloud native stack for Percona monitoring and management, which is a cool tool to monitor and manage your databases. It's also open source, and also for our Percona platform. You can find me on LinkedIn, or I don't know if you heard about this new open source Fostodon or Mastodon network. It's like a Twitter replacement. I just joined it, so I'm pretty excited. Please join as well and follow me there. You'll be one of the first followers. So this is the agenda. We're going to talk a bit today about where MongoDB is today. What kind of options do we have today for MongoDB as a service, and why would anyone want to use MongoDB as a service or have it in their environment? And we're gonna obviously talk about Percona way of providing MongoDB as a service. Hopefully, I'm also going to show you some quick live demo of how does it look like from our standpoint. So MongoDB today, I hope everyone here knows about DB engines. It is the website which tracks the popularity of all the database engines and database management systems, how they call it. They use various signals like press chatter, community engagement, probably number of installations or mentions in some articles and so on. And today, MongoDB is number 5 in the whole ranking. And it's a good result. Number 1 is Oracle, then I think it's MS SQL, then MySQL, then Postgres, and then MongoDB or something like that. So, but it's still number 1 in the document stores category. All the competitors in document stores are way, way below in this list, which is a great achievement. And if you look into DBaaS, database as a service, the only viable and fully functional offering is MongoDB Atlas in this space. There are some other offerings. For example, DigitalOcean, they have their own MongoDB as a service, but it doesn't have sharding, for example, and so it cannot be called like fully functional, but it can work for someone. But the like viable option that can be deployed anywhere is MongoDB Atlas only. The issue is simple. There is this license, SSPL, that MongoDB is licensed under. And this license kind of is very strict. It's not open source license according to open source community. And this license actually does not allow you to provide a like paid service for MongoDB. So you cannot just sell it anymore. You can use the code for your own use cases, for your internal deployments, but you cannot like make any financial revenue from it. And obviously, the last but not least, MongoDB is loved by developers because it's super simple. You just throw the data there and it works. You don't need to think about the structure. It's not relational database, it's document database. It's really easy to configure. It's really easy to deploy. They have awesome onboarding experience for MongoDB Atlas or for Ops Manager, for other tools. It's really cool. That's why developers love it. So this is MongoDB today. Let's think about MongoDB journey in a company. So let's imagine that you're either in a small startup or you're spinning up a new project that requires you to have MongoDB, and some application is going to use it. So there are a bunch of ways how to do it, but usually it's like a starter kit way where you have the application, it doesn't matter which language it is, and you want to deploy a MongoDB database. So what you do, you just deploy MongoDB. Either it is a container, or you spin up an EC2 instance and then load the packages and somehow start MongoDB. That's the easiest and the fastest way to do that, and probably the cheapest one. And manual and quick, right? Now you have an application, you have a database, everything is working as expected. You probably give access to your developers to access the database, to write some data, to modify it. Everyone is happy. The problem here is that it's still manual approach where you cannot fully enjoy MongoDB, where you cannot automate a lot of stuff. And if you need to deploy the database again, like you have another application coming in, or you need staging environment, you need to do it manually again. And it's a big problem. I'm not talking about like day two operations, like scaling backups and so on. Another question here is obviously it's hard to scale such an environment, because to add one more node to your MongoDB replica set, for example, again, you need to do it manually. You need to configure it manually, and it's a painful process. But it is a starter kit, right? It's working well for everyone. Just try it out, and it works. The next step here would be to automate your starter kit. So you come up with some cool infrastructure as a code tooling, or some, I don't know, bash scripts or whatever, or GitOps approach. And you automate the deployment of your application and your database. And it works super fine for some time till you see a couple of problems. Problem number one, now you need to maintain all these scripts. So yes, it can be simple. It can be like 20 lines or 40 lines Terraform script that is easy to maintain, or it can be Jenkins pipeline that you have expertise with, but still you need to maintain it. And it becomes harder and harder once you realize that your environment grows, your requirement kind of differs from one environment to another. And now it's becoming really hard to manage all your databases. If you have not 2, not 3, but 20 databases, you need to upgrade them. You need to ensure that they are secured in terms of users or exposure. You need to make sure that they perform. You need to monitor them. You need to scale them, and so on. So there are lots of day two operations that you need to perform here. And with GitOps or with Terraform, you can do that, but it's a nightmare. And also the third problem here is there is no self-service. Self-service means that if your application or developer needs a database, then they can just click a button and get the database right away. But you don't have it here. You can make it somehow, right? Someone can go and modify your GitOps your code in Git, and then your GitOps pipeline is going to apply the changes. But it's not a good approach sometimes, because it's still not a self-service. Someone is reviewing your code changes, applies them, so it's the same as a ticketing system. So it's not a real self-service. Now, why do we need a self-service, really, right? In a nutshell, what self-service does is it accelerates innovation, specifically for developers. And what it does for DBAs, it removes toil a lot, right? So instead of developers sitting in the queue and waiting for someone to provision the database, developer just goes to the API and gets the database, gets the application, whatever. It's like how any public cloud works, right? Another important thing with self-service is that usually when you provision a database through the API, there are some subsets of predefined configurations which are already compliant with your requirements. So they're running the version that was approved by your security department. You know that the data that is uploaded to this database is safe. I mean, maybe it's obfuscated if you have some personal information there, and so on. And obviously, if you have an API which can provision a database, then it can be easily integrated with your existing platforms, whatever you use. It can be, again, some Jenkins CI/CD pipeline, or it can be some platform of your own choice, like Cloud Foundry, or something that you developed in-house. It still can be easily integrated. And the thing is that if you really need a self-service and you're tired of maintaining scripts, then you don't have any other choice in MongoDB space as use MongoDB as a service, right? And this is like the third iteration here. The first one was manual. The second one was to automate it with your custom scripts. And the third one is MongoDB as a service. And if we look into the MongoDB as a service space, there are not so many options. And option number one, obviously, is MongoDB Atlas. Yes, it is self-service, and it's like zero maintenance. You click the button in the nice UI, and you get a database up and running. You click a button, you get the backup. You click a button, you get your storage encrypted. Everything is fully automated and magical. There are a couple of problems with that. First, it costs a lot. MongoDB Atlas is very expensive, especially when you scale. At first, it's not expensive. You have a couple of servers that works fine for you. But when you scale and your servers grow in size, you have more and more storage, it costs a lot. Another problem is vendor lock-in, and it's really important for enterprises because right now you cannot easily escape MongoDB Atlas. If you want to replace it with something else, there is almost no alternatives. It's number one. And also it's really hard to stop using it because it's a painful process to migrate to something else, right? There are some other alternatives though. There is Azure Cosmos DB and Amazon Document DB. They also come with self-service. You have an API, you can call it, you get the database up and running, and it has almost zero maintenance cost, which is also awesome because for you as a DBA or for you as a developer, you don't need to think how does it work. But again, there are some problems here. Problem number one is, again, cost. It costs a lot, especially, again, when it scales. Vendor lock-in, similar story. You either lock into Amazon or Azure in this case. And there is a misconception that if you use MongoDB, then you can use any other MongoDB in place, right? But it's not right for Cosmos DB and Document DB because they do not provide full MongoDB compatibility. They provide MongoDB protocol compatibility, but not in full. And that's the problem for a lot of people who are using MongoDB, that these solutions are not like a 100% drop-in replacement. And finally, we go to the Percona way of doing things. What we provide, I'm going to look into later a bit on the next slides. But what you need to get is Percona MongoDB is a drop-in replacement. So we have Percona server for MongoDB, which is a drop-in replacement for MongoDB. It's not only MongoDB compatible, but we provide similar enterprise functionalities like audit, LDAP, and KMIP integration, and so on. And on the next slides, you will see why it is still providing a self-service. So let's talk about Percona way, how we do things. What we chose is we chose the path of Kubernetes operators. If you do know what Kubernetes is, great. If you do not, the quick explanation here would be that Kubernetes is a container orchestration platform. So you have a lot of containers, Docker containers, and you need to orchestrate them from one virtual machine, from one server to another. That's what Kubernetes does. It just automates all this magic. And Kubernetes operators is a concept that was introduced some time ago to automate application management on Kubernetes within all these containers. Because once you have 1,000 containers, it's really hard to manage all of them. And the applications, they're becoming more and more complex, and it's really hard to manage them all. And with Kubernetes operators, the way that developers and engineers work is that they interact with Kubernetes API. They just send a command and say, hey, please provision me a database with 3 nodes, with this amount of storage and CPU and so on. And Kubernetes operators do the magic there. You don't need to do anything else. You see this gray area here? You don't need to know what is happening there. Operator is doing everything. It provisions all the Kubernetes primitives, all the containers, it configures the database. What you get, or what your developer or teams get, is just an endpoint. So this is the definition of a service, where you click a button and you get something out of it. In this case, in case of databases, is you get an endpoint that you can connect to and use your database. That's it. That's a self-service experience, right? And Percona has multiple Kubernetes operators, but today we're going to talk about Percona operator for MongoDB. First of all, it is open source. So we do not ship any code which is not open source to our users and customers. You can find the source on GitHub. As I said, it's 100% MongoDB compatible. And on top of it, we'll also provide enterprise features which are source available. We cannot say that it is MongoDB open source, because still we use MongoDB community version, and on top of it, we add some enterprise features, so it's source available. It is production grade. We have lots of customers who use our operators on MongoDB software. With operator, you can deploy MongoDB in various topologies. What does it mean is that, we support some basic stuff like arbiters, non-voting nodes, sharding, and so on. But also you can go multi-region deployment, where you have 2 regions, one of the East Coast, another one on the West Coast, and you set up the replication between 2 clusters or in a single replica set across these 2 regions through the operators. And again, you don't need to be an expert in MongoDB, or you do not need to be an expert in Kubernetes to do so. As for management and maintenance, this is one of the keys of any service, is you don't need just to deploy your database, right? You need to manage it somehow. You need to ensure that your data is safe, so you need to back up and restore it freely. You need to scale it if you have an increased demand, or you need to scale it down if you see that the load is dropping, so you don't want to waste resources. Upgrades, everything is possible through the operator. And again, it doesn't require you to have any MongoDB knowledge or any Kubernetes knowledge. You just send the command to the Kubernetes API saying what you want to get, and you get it. It just works, right? So this is another alternative for MongoDB as a service. And one thing here is that, yes, you can think that, okay, this is free, but it still introduces a lot of maintenance for me because I need to manage Kubernetes. Well, this is partially true, but with public clouds, for example, Kubernetes can be deployed in seconds or, in minutes with a click of a button, and you don't need to have any expertise. It's still like a service. It's Kubernetes as a service, and it just works. But the beauty of Kubernetes here is that it can run on any other environment. So you avoid vendor lock-in here, because you can deploy your Kubernetes on-prem or on any other cloud, and you can easily migrate your workloads from one Kubernetes to another with Percona operator, and it without changing a piece of code in your application or anywhere else. So it's full non-vendor lock-in experience, which is awesome and great. And taking it to the next level, this is where probably I'm going to show you some demo. Is I mentioned before that also we have Percona monitoring and management. And what Percona monitoring and management has, it also has DBaaS capability, database as a service. What it does is, instead of talking to Kubernetes API, so that you don't want to do that, you can set up PMM, Percona monitoring management. It's going to give you the UI or API that you can interact with, or your application can interact with, to deploy databases easily. So in this case, you do not need to have any expertise in Kubernetes at all, like zero. You don't need to craft any YAML manifests or something like that. It just works. And on top of it, you also get observability, management, insights capabilities that are coming with monitoring and observability stack of PMM. Hopefully I can show it to you quickly. Let me try to figure out how can I share my screen. Layout. Okay. I think I'll click stop sharing. Okay, I think I'll need to call in Stacy to help me out with this one. Okay, now I see the button, share. Okay, yeah. No, Stacy, I'm done. I found the way. Okay.
Just wanted to make sure.
So, okay, yeah, thank you. Can you see my screen? Right? Okay, this is the installation of Percona monitoring management. I just installed it. I was 17 for some when I was 8, so hopefully everything goes smooth. So I'll log in now into this. Okay. So yeah, I don't need a tour. So Percona monitoring management comes with DBaaS, but DBaaS is in tech preview stage for now, so you need to enable it. I'm going to do it here. So you enable it in the settings, apply, and the next thing would be to go to DBaaS. Yeah, the way it works is that once you have PMM installed on your Kubernetes, you can install it outside of Kubernetes, but in my case, it's installed on the Kubernetes cluster with the Helm chart. What is happening is that PMM registers the Kubernetes cluster it's installed on. So it registered my Kubernetes cluster, and it automatically installed the operators. For now, it's MySQL and MongoDB, which means you can deploy either MySQL or MongoDB cluster. And then you just click create database cluster, and out of all the settings, you can click next, next, next. But in my case, I will enjoy going through some advanced mode. So it automatically picks MongoDB, and when you go to advanced options, you can pick the version of MongoDB. You can pick whether you want a cluster. By default, it's cluster or single node topology. Single node is obviously not recommended for production, but it's okay for testing. Number of nodes in your replica set. Also, do you want external access or not? It means that in case of Kubernetes, it is going to expose your database through a load balancer if you enable this one. And you can choose the size or pick a custom size here, like number of CPUs, memory, and the size of the disk that you're going to use. The disk, by default, it provisions the storage on your cloud provider with the default storage class. I have, I think it's GKE cluster, so it's Google Kubernetes engine, and by default, it's going to provision SSD, default SSD storage, so it's going to provision 25 gigs volumes. And then just click create cluster. I'm not going to wait till it's going to be created. It's going to take a couple of to provision. But once the cluster is up and running, have action string to connect to, you're going to have the login and password and the IP address. So everything is going to be shown here. You just connect and start consuming it. That's how PMM simplifies the interaction with Kubernetes. So again, you don't need to know Kubernetes at all. It just works out of the box. You don't need to know how MongoDB works. Again, it just works. And it's all open source. You can install it in your own environment and just start using. As long as it's technical preview, it comes with some improvements. So you might see that some things are not polished yet, but we're working on it, and it's going to be general available and fully ready for production in Q1 next year. That's the plan. Okay, how do I stop sharing? And I think I'll click on the slides again. Okay, share. Okay, I'm back. I'm back to the slides. I'll need to pick the slide. Okay, so before moving forward, again, to capture the idea here is that Percona way of doing database as a service, or in this case, MongoDB as a service right now, is through Kubernetes operators. So you have a Kubernetes cluster, and you can deploy an operator here, and it's going to do all the heavy lifting to provision the database cluster or clusters for you, for developer or for your application or for your CI/CD pipeline. The experience is similar. You just execute a command and you get the endpoint to connect to, and you start using your database. You can scale it, you can back it up, you can monitor it. It has nice and smooth integration with PMM, so everything works fine. If you don't want to touch Kubernetes at all, you can use Percona Monitoring and Management DBaaS, which is in technical preview right now. And again, it's fully open source and can be installed anywhere and use any Kubernetes flavor. Going to the next slides, it's the final slides, I promise, is there are a lot of myths around Kubernetes. That myth number one is I need to be a Kubernetes expert. The truth here is, if you are not using operators, definitely you need to be Kubernetes experts. Because if you provision MongoDB without operator on Kubernetes, you need to provision Kubernetes primitives like stateful sets, pods, services, roles, everything. PVCs, you need to do it yourself. And it's definitely hard, it's definitely complex, and would require some Kubernetes expertise. But if you use operators, you don't need to know all the details how it works. Yeah, you need some basic understanding of how Kubernetes works to maybe troubleshoot problems. Like if your MongoDB scales, then you need to scale your Kubernetes cluster as well to add more nodes or add more resources. That's the basics, but you don't need to be an expert in everything, because operator does all the heavy lifting here. And obviously, a operator is making sure that your MongoDB is going to recover if you lose one node or something restarts, because containers and Kubernetes as a whole is an ephemeral environment where things can come and go easily. And you need to be ready for that, but operator is taking care of it easily. Another myth here is that performance on Kubernetes is poor. We hear that a lot from users and customers, that there is a concern that, okay, if I move database to Kubernetes, then there would be a significant performance degradation. And I like to say that performance is as good as your hardware on Kubernetes. So if you have a good instance, a good server with good storage and great networking, then this is where your performance is. Because Kubernetes itself does not introduce performance penalty. There are lots of papers on how containers outperform KVM, for example, or how they perform at the same level of bare metal machines. The same thing is for Kubernetes. Kubernetes just orchestrates things. It does not introduce any performance penalty. You can see some performance penalties on networking, because networking Kubernetes is very complex. But I would say that this performance is going to pay off because of container density, because you can pack a lot of containers on a single instance, and that kind of pays off. Also, you can look at it as a evolutionary story. If you remember, like 20 or even 30 years ago, when virtual machines appeared, database engineers were skeptical about moving their databases from bare metal servers to VMs. Or it wasn't even like that, like 10 years ago. And there were similar concerns, like performance is going to be bad. But look at today, right? Today, all the workloads that we have in the clouds are running on VMs. And no one is thinking that, okay, if I run my database on EC2 instance, it's going to be performing poorly. No, it's not like that, right? And it's the same with containers. So right now, containers is taking over from VMs because they provide better density. And with Kubernetes, which is becoming de facto standard for cloud native workloads, it's becoming more and more easier to run your workloads in such environments. And the last but not least, myth number 3 is Kubernetes is not ready for stateful workloads. So there are like 96% of organization, according to the latest TNCF report, they run Kubernetes. 96%. They run or think of running Kubernetes. It's a lot, right? So everyone at least tried it, almost everyone. But what is more interesting is that there is such a community called Data on Kubernetes, DOK, and they recently released a report a couple of weeks back. And in their report, they state that 81% of organization, they already run or plan to run operators for stateful workloads on Kubernetes. So it's a lot, 81%. Yeah, maybe it's not in production, but still it is a lot, which tells me that, yeah, Kubernetes is ready and it's been heavily used for stateful workloads. And to confirm that, down there you see a list of pretty big names, pretty big vendors, like VMware, Nokia, IBM, Broadcom. All this company, they run a lot of stateful workloads in production on Kubernetes. For example, PlanetScale is the company behind VTAS, which is a MySQL sharding solution. They have their own cloud, and on that cloud, they use Kubernetes operators to run databases in production for a lot of customers. VMware and IBM Cloud, well, for VMware, they have Tanzu, and they have their own operators to run databases on Tanzu in production as well, and they do it in a huge scale. On IBM Cloud, every database that you deploy through their cloud is running on Kubernetes. That's how interesting it is. So this myth, I think it's like completely busted. This is all from me for today. So I hope I covered the topic of MongoDB as a service. I didn't go deep into technical details and how it works underneath, but I think you got the idea, and I really encourage you to try Percona products to run MongoDB in your Kubernetes environment with PMM or without it, just with operators. Let us know how it goes. and we'll be glad to help. We're an open source company. We're very friendly and receptive to feedback. Stacy?
Thanks so much. We're going to switch over to our next speaker.
Hear me all. Thanks for joining the Tech Days. This particular talk is going to be about MongoDB resharding. So we'll be taking a look of what exactly resharding, why it was introduced in latest 5.0 version in MongoDB. So before going forward, a bit about myself. So my name is Wieremjewicz. I'm from India. So I work in managed services here at Percona, and I've been with Percona for more than 2.5 years now. I have roughly 6+ years of expertise around MongoDB. I'm basically from Noida in India. So this is what about in the agenda for this particular talk. So we'll be taking a quick recap about what exactly Mongo sharding exactly is, why it is needed, what are all the common issues people run into when they start using sharding, and what's the best time when you basically shard your database. And then we'll take a look about the evolution of MongoDB resharding and how it's implemented, how it works internally. And then finally, we'll conclude with the considerations and limitation that comes around with the same. So I think most of you might be familiar with MongoDB sharding, but let's have a quick recap about the same. So sharding in general basically means when you partition your data to across multiple servers. So in order to achieve this scalability for your database. So when I talk about scalability, there are a couple of ways where you can scale out your workloads, right? For example, you can have vertical scalability, you can have your horizontal scalability as well. So both might depends, or both works according to your use cases. But as your workload grows to a significant amount of size, right? For example, there would be a better option to go with this horizontal scaling. That's when sharding get introduced, and that's when you actually start implementing sharding within your database clusters, right? So in terms of MongoDB, there are different components within the sharding cluster as well, wherein your data will be partitioned, right, based on a certain scenarios, right? So roughly, there are three types of sharding in MongoDB. One is range, another is hash, and last but not least is zone sharding. So based on the use cases, you can go ahead with whatever the sharding method works out for you, right? So I'm not going to deep dive into those what all the different shardings we have available. And another thing is there are few components in the sharding clusters, right? So one is MongoS, another is config server, and then comes the shards especially. So shards are basically the component where your actual data gets resided when you partition them, right? And config server basically holds a metadata about your location of that portion of the data, where exactly that piece of the data is located on which particular shard, right? And MongoX is basically acts as an intermediate with your application towards your actual data which is located in your shards, right? Basically routes the query on a specific shards based on what type of query you are running against, right? So now that we got an idea about what exactly sharding is, now that you have implemented sharding, there are a few common issues that may run into, right? So there are few of them which you will be able to see right now. So there might be others, but roughly on majority of the cases, people run into these kind of issues. So first of all, how are you going to do a sharding, right? You pick a shard key, wherein based on that shard key, your data will be distributed across multiple shards. So now that I have seen a lot of people, not able to choose a better shard key for their environment, and they end up being unevenly distributing their whole data set across multiple shards. So let's say few of the shards has 70 or 80% of data, and remaining has like 20-30% of data. So what happens? There is uneven data distribution now, and based on that, your workload is not be efficient enough, right? Your few of the shards which have more data will be receiving a lot of workloads, a lot of queries will be hitting them, and other shards will remain the same. They won't be receiving that much amount of workloads. So that is one of the problem, right? Another thing is basically, let's say you have sharded on a particular fields, and those particular fields you're not going to use in your query itself. So then what happens, you will end up gathering your queries to different shards altogether. So the solution for that is to basically include those fields which you have added as your shard key in the query hitting from the application end itself. Okay, the last one is what about the chunks migration error, which you usually call. So what happens generally, there will be a lot of jumbo chunks gets formed. Now, what jumbo chunks are basically when your default chunk size gets exceeded. Let's say the default is 64 MB for a particular chunk, right? When it reaches beyond that size, the balancer will not be able to split it and then able to migrate it. So there are different ways to mitigate that issue. You can either use split add, split find, or manually split that chunks, but sometimes that's a manual process, right? So these are the similar issues that people generally faces. Now we are going to take a look at how you can actually going to overcome that. So this we have actually covered in the previously, so I'll just call out once more time. So in order to basically achieve the horizontal scalability, that's the point you're going to implement sharding within your database cluster, right? Based on your workload, based on your application usage, you will pick the best sharding method applicable, right? So like one of the important one is about the zone sharding as well. For example, due to data locality or application locality and compliance regions as well, you pick zone sharding as well, wherein multiple shards will be located geographically, and based on that you will partition your data so that you can geographically distribute the data accordingly and then accessible from your applications end. So this is the reason why and when should you shard basically from the replica side if you have existing. So now what about the evolution of MongoDB sharding, right? So it got evaluated like from beginning, like in the previous version, older version like 2.6, 3.0 altogether. Until 4.2, there were no way you can change the shard key. If you end up in those common issues which we have discussed, there was only couple of options where you can basically try to fix those issue. One of them is basically dump the entire collection which you have sharded and then able to restore into a new collection with a new updated shard key. So that is basically an offline process where you have to take a consistent backup of your existing collection, stop all the writes, and then able to restore to the new collection, which is going to take a lot of time if you have very large collection in context, right? Another option is basically to start some kind of a synchronization or live migration protocol to a new collection, and then once those gets in sync, you will basically redirect or switch over to the new collection, get rid of the older one, which is the new one is basically with the updated shard key which you are intended to use now. So until 4.2, everything was a manual approach, which was quite complicated and tedious task to be followed. And then comes MongoDB 4.4, wherein they have introduced refinable shard key. Refinable is basically wherein you can add a suffix to your existing shard key. Based on that, you can tweak around some the cardinality and frequency of your shard keys, and then the balancer will be able to evenly distribute the data. But this is basically comes with a lot of complexity as well, because your existing shard key may not be optimal enough even though you have added a suffix or you refine your shard key, right? And then finally comes MongoDB 5.0, wherein you can completely change your existing shard key with a new one, right? So you don't have to do any kind of a manual approach for the same. It's a live process. It's not going to take a lot of efforts from your side, from the user end itself. So as you can see, this is the basic syntax for that. You will pass on the full namespace wherein you want to change the shard key, and you can update or provide a new shard key which you're going to use now. So now we are taking a look at how it's going to actually work internally. Okay, so there are a lot of steps, a lot of process that's get implemented underneath. That's how it made it work basically. So when you trigger that command, which we have seen in the previous slide, it creates a new collection which is called a system.resharding dot the UID of the original collection, right? And what happens is basically it copies and starts cloning of your existing collection to this new collection, and at the same time all the shards which has that collections as a sharded, right? It maintains a temporary oplog buffer as a collection as well, to basically whenever there is a cloning goes on for the existing collection, any incoming writes operations to those shards will be get stored in a temporary oplog buffer collection. And then once this cloning gets completed, those temporary oplog buffer that was stored earlier on each and every shard will then start to be applied. So there is a whole lot of stuff going around in the back end, but there's no manual efforts from our side itself. We just need to run the command. Everything goes into the back end. And then once the cloning and the application of those incoming operation via oplogs gets applied to the new collection, there will be a couple of seconds lock, which is usually known as a critical phase, as you might have aware about how the actual chunk migration happens. So it takes a couple of second lock basically to update the new routing table entries into the config server metadata to know the new exact location of the chunks which are now a part of the new collection which you have resharded. So in a layman ways, these are all the steps that are going to be applicable in the backend. And then if we'll take a look at like obviously you might have ending and if it is some kind of a let's say if you have chosen a batch shard key again, like if there's any case you want to terminate that operation at all. So this is the command which you can particularly use to abort that entire resharding process as well. I would suggest don't use kill op from the current op. That is not an optimal way to do that. Use the support reshard collection command. So basically it takes care of everything for you. It rolls back whatever it has done until now. So if you end up being in a situation where you want to terminate the resharding operation, just follow this command. That would be great for you. Okay, so now if you'll ask me how can we monitor the progress at all, right? So there are a couple of ways. In a real time, you can just go ahead and run this aggregation pipeline with the help of current op. So you'll get to see what exactly is happening. So in the later slide, we'll get to see what exactly the output from this pipeline. But for now, you can run this, get an idea what exactly happening in the real time. Another thing is to look into a changelog collection, which is inside your config server replica set, inside your config database. So this is a collection where you can query with this resharding coordinate transition command. Look for the field and basically sort it, so it will show you what all the different stages is currently going through. So these are the roughly two ways where you can monitor the progress. Okay, so this was my setup. So if you can see, I had POCDB and a POC collection. I had intentionally sharded as a range shard on top of underscore ID, which is not obviously an optimal way to do since it's monitoring and increasing, as you might have aware. So I have chosen the shard key. Now I wanted to choose a different shard key altogether, right? So what I'm going to do now, I have ran the command. Now that you can see within that database itself, it created a new collection, like I said, with the name of system.resharding dot the UID of the existing collection. So the collection, the source collection was POC call. The UID is mentioned here. It created a new collection with prefix of system.resharding and then the same UID. And then I can basically, like I said, query the changelog collection with this particular condition, and this starts showing me. So as you can see, I sorted it with the oldest phase. So I started initializing, and then basically starts cloning the new collection from the existing one, right, until this point. And then I kept looking and querying the same collection. At the same time, I wanted to look what exactly happening to each and every shard. So I went onto one of the shards. As you can see, there are these are the basically the temporary collection that got created, which are basically holding the incoming write operations at the point when I executed that command, right? So beyond the cloning, there has to be a way to buffer all those incoming write operation, and then once the cloning gets completed, they can be applied. So these are the temporary collection for the same progress. And then after some time, I queried the same changelog collection. As you can see, after cloning, and then start applying all those oplogs operation that received from each and every shard, right, respectively. And then this is a critical phase which I was talking about. As you can see, after applying all those incoming operation, it holds a couple of seconds of log to update all the metadata route entries in the config server metadata. And there was another way as well where you can monitor the progress, which is using current op. So there is a slightly different output which you will be able to see in current op. Is like how much amount of documents were there originally and how much is being applied. Similarly for oplogs as well, how many oplog entries were fetched and get stored in those collection and how many got applied. So it depends like what exactly the current stage is, and based on that you will be able to see that output in current op. And then finally everything gets committed. Your old collection which you now have resharded gets dropped, and then this new collection which started with system.resharding gets renamed to the existing collection name. So that's how the entire process will look like. And then you will when you will run the SSO status, you will be able to see that the shard key got updated and your chunks gets balanced. So this was the whole process underneath. So you will be able to monitor as well if something goes wrong, like how to abort that operation at all. Okay. Now there are a few considerations and limitations as well around the same. So first of all, you need to find out how much is your storage size, or I would say a compressed size of the source collection. And you have to make sure that you have 1.2 times of disk size available for that partition, where you're going to reshard it, right? So if you don't have it, it might end up having some space issues. So make sure you have 1.2 times available of the existing collection storage size, or I would say compressed size. And make sure IO capacity and CPU load both are below 50%. The reason behind that, whenever this operation gets performed, there's a lot of activity going on in the background, like the cloning, the application of incoming oplog operations, right? And on top of that, your existing collections is still serving the traffic. Your existing shard cluster is still serving the traffic as well. On top of that, this may adds a bit of overhead as well. So make sure that your IO capacity or IO is not peaking beyond 50%. Same with CPU spikes as well. So make sure you're evaluating the current resource utilization of your cluster, and then plan this activity. Okay, there are a few more considerations and limitations as well, right? So let's say you have changed your shard key. Now that you have to also make sure that you are using the updating shard key in the application side itself. If not, you will end up in the same issues wherein most of the queries are now ended up being in a scatter gather manner, right? So whatever the queries you are triggering from the application ends, make sure that you are including that new shard key in them. So there has to be some coordination with the developers end as well. So accordingly, you can fully utilize this basically the feature we have implemented. Okay, so this is a bit of consideration where it's get overlooked most of the time, so don't forget about that. Okay, so while you perform the resharding, there hasn't been an index build available for you. So if you try to perform a resharding where an index is already building, a similar kind of operation where it's having a global lock, resharding will not be available for the same. Similarly, when you're performing these kind of operation like delete, find and modify, update one, while your resharding is going on, these might not work for you. So once post completion of resharding, you will be able to run these command. Similarly, you can only reshard one collection at a time. So once that is completed, you can continue going on to reshard another collection, but not more than one at the same time. Obviously, you cannot add a shard, remove a shard, or drop a database, create a collection within the same database, since it's basically holding a global lock for you. So you have to make sure that these operations will not be applicable as long as your resharding is running. So let's say if you're doing resharding on a very large collection, you may need to take care of these operations, like if they are more frequent from your application's end. And to summarize, basically, to summarize my talk, I just need to include few points here. Do not afraid to horizontal scale. I've seen a lot of cases where people think that horizontal scaling among MongoDB sharding is basically a complex architecture when it's not able to manage properly. So don't be afraid to do that. Now that we have different options available, earlier it was just about the shard key, that what if I end up choosing a bad shard key and my data is not distributed. Now that we have this new feature introduced in 5.0, so try to explore it, and don't be afraid to do that. And another thing is don't be too early or don't be too late to go into the sharding, because if you are sharding bit early, right, if you don't have a significant amount of data set, if you are sharding, obviously you have to take care of a lot of things, not just about cost factors. It's about maintaining the backups as well. And if you are sharding very late, let's say if you have a lot of data set, lots of collection, and then you're performing the sharding, it will be an overhead for you, because when you perform the sharding, lots of migration will be happening from one shard to another. Adds an overhead to an existing workload, right, coming from the application end. And obviously you might be aware of how basically you should choose a shard key for you. So make sure that you have a field which has high cardinality, high frequency in the queries. What type of nature of field is this? A monotonically increasing, or if it's a range based query workload from application? So make sure that you evaluate all those things, and based on that, go ahead with that kind of a sharding which is suitable for your case. Well, that was all about my talk. I hope you enjoyed the session, and you can reach out to me, look into the career section as well. Any questions available, just drop into in Q&A section. We'll be happy to answer that.
So today we're going to be talking about MongoDB, and we're talking about Percona server for MongoDB as well, and version 6 and what's up, and different types of things. We're also going to go ahead and do a little overview first. So I'm the MongoDB technical lead here at Percona. For that, I've done quite a few other things. I did Oracle for a long time. I worked for Bioware, a studio for electronic arts, and did Star Wars: The Old Republic MMO game. I also switched from doing Oracle for a long time straight into the fire hose and started doing MongoDB support for Object Rocket, which was a lot of fun, very interesting. But other than that, it's just many years of database. So today we're going to talk a little bit about the overview. I'm assuming that you guys know all of this, but I've got a lot of slides, so I'll probably blow through quite a few of them, but just going to kind of do a quick overview and then talk about growth and trends, and then the versions, the changes, and those type of things. And then problem solutions, and if we have a little time, do a quick peek at PMM. So. All right, so MongoDB comes from humongous, the word, a long time ago. It's a document data store. You heard Sergey say earlier that it was number 5. It's on the DB Engine's ranking list. So it actually used to be number 4 probably in 2015, 2016, but it is the top NoSQL database, non-relational database that's out there. And so it kind of treats things differently. You have collections as opposed to tables. You have documents as opposed to rows, and the object IDs. And really one of the reasons is a long time ago, but there still are, there are a lot more developers and software engineers than there are DBAs and sysadmins and that type of thing. So they didn't want to have to do the structure, and with them being more, they won. They've got the flexibility. But MongoDB really does have the flexibility, and that's actually one of its huge strengths and one of the things that led to its growth. Okay, so unstructured, it can handle unstructured, semi-structured, and structured data. So, chat logs, documents, things missing a field and records in there. So, and the idea was always just kind of throw it in there and we'll deal with it later. The other thing is it's denormalized. You don't have to worry about, the relations and the joins and all this. You can put duplicate data in multiple tables and deal with it, and that's fine. So another big strength of it is that the MongoDB, you can use the aggregation pipeline. And what that really means is that you can do your lookups, you can do your matches, you can do some analytics operations all through there. So in a little bit, we'll talk a lot about time series collection. So kind of skip over that one for now. So here's kind of an idea. So, I mentioned relational and non-relational, so SQL and NoSQL. And then here are some of the ones, right? Relational databases, Oracle, MySQL, Postgres, SQL Server. And then non-relational databases, MongoDB is the top one. But then you also have the search engine one like Elastic, like Solr, like Lucene. And you have the graph databases like Neo4j and Redis, which is your historical in-memory, and then InfluxDB, which is your time series database, so which is super important with the growth we have. All right, and so there are multiple different types of setups. You heard Divyanshu talk a little bit about that, but you've got your standalone, then your replica set, and your sharded cluster. So we don't really need to go over that, but the idea is you scale horizontally via sharding. It's not vertically up, and you can use commodity hardware. So that was allowed it to be a lot less expensive. So that always made people pretty happy. So, so why do you want to look at NoSQL? Why do you want to use it? Why Mongo? Well, the data growth is really the underlying answer, right? It can handle the velocity, it can handle all the different types of JavaScript, JSON, has tons of drivers that are popular and supported, and then the variety of data. Okay. Again, all the things here, now you've got all the new features that are coming about, performance. The biggest thing, the relations, the databases, right? The joins that were caused in the relational databases, they weren't able to handle the massive amounts and the speed needed. And so you were having queries that were taking a long time. And what the document DB and the duplication of data came along, it allowed the tons of data that ever since social media started, really was the beginning, but it allowed you to have fast responses, millisecond, sub-second response times instead of waiting. Imagine if you're trying to play your game, which, happened back when we were working for on the game initially. But if you have a delay and you're playing a game, that's actually not a great thing. So, and even batch analytics, if you think back to like Exadata and any of the large data warehouses, back when it took like 24 hours or more to run the massive queries and the massive things that you have. And so that's what has come along. MongoDB and these types of databases have allowed that to not happen. The other thing that's huge, again, it has a built-in underlying native from the beginning replication and the redundancy. So from the beginning. Some people say it has an easy button. So to me, the replication actually, because it is so native, it is pretty easy as long as you get your config files and those types of things set up correctly. If not, you have to spend a lot of time hunting and pecking. So I talked a little bit about the data, about the growth. Well, here's some stats before we get into it. Like, why do you really need it? These are pretty eye-opening stats. If you look at it, so a zettabyte, right? 175 zettabytes by 2025 is actually what we're supposed to have. Now, that's a lot of data, right? So by 49%, by 2025, all the worldwide data will reside in a public cloud environment. That's the prediction. So 30% will need real-time processing. So it's no longer this huge amount of data. It does not need to have the batch processing, the analytics. It needs to be more available. Okay. And so here are a couple of things. How much is a zettabyte? Exactly. Yes, how much actually is a zettabyte, if you stop thinking about that? If you downloaded 175 zettabytes on the largest hard drive, it would take 12.5 billion drives, okay? You could go to the moon 23 times. So only to the moon, not back though. So a lot of one-way trips there. But if you talk about the data creation, the other thing that's happening is not just the data creation, It's the data utilization. It's the beginning of data as a service. Not necessarily possibly at the beginning, but more and more and more, which we all know that our data is used for analytics and for immediate near-time analytics. So there's some other trends going on, right? So I don't know if you've heard about the data mesh. More and more things. You have their large databases. You have your online data warehouses like Snowflake, which store in the market, but you still had to put everything and send it somewhere else, right? With the data mesh and the edge and the distributed computing, right? And then the beginning of 5G. So, and then all the drivers, your cell phones, your refrigerator, your Ring cameras, all the IoT, all the sensors. You're soon to be, autonomous driving, maybe possibly, but all of the sensors that are now there on the cars. Okay, so the top 4 industries, 50% of the global amount of data, and that's going to be in manufacturing, financial services, and blockchain. Yes, despite the crypto crash, right? Healthcare, digital health, and media entertainment. But you look over here, you have all of these other things. You have endpoint, you have vehicles, you have mobile, you have assets. Just so many different things are having the data. Okay. I mentioned this a minute ago, but the monetization of data, right? So actionable business insights. You're going to take the data that you have, you're going to analyze it rapidly while it's happening, and then you're going to sell it as service for money. We've seen multiple companies do that, and some of them have kind of gotten a bad reputation for that, which is understandable. But it depends on where you're looking, where you want to be for that. Right? So the use cases, these are the old use cases, the new use cases, right? All of these different things. So you've probably heard a lot about legacy, modernization, and migrations, and fintech, customer analytics, just a lot of different things. But this is a pretty interesting area, right? Your cars. The amount of sensor data around your cars that you're putting in now, whether it's autonomous or not, it's not autonomous yet at this point, really. But the amount of sensors that are around your car that beep at you when you're going to try to signal lane, I don't know about you, but when I know that I want to change lanes and I put my blinker on and I'm waiting for the car to move out of the way, out of my thing, and the car beeps, that's not the best. That's not the best thing, right? So, but the fast data growth. So, where's your car? Robotaxis are coming. In some places, they're actually already around, so they're ahead of the time. But they're expecting this to be a $2 trillion industry by 2030. Okay. And it's not just Tesla. You have, Zoox, and you have multiple other ones as well. Okay, connected devices, sensors. This is a huge one, though. People don't necessarily think of this. It's healthcare, IoT. So wearing sensible devices that also send health information back, the Internet of Things in healthcare. And it's huge. It's a huge area. So we have all this data, right? The number of connected data devices, 38.6 billion. That is a lot of devices. How many devices do you guys have at home or that you carry around? 2.5 quintillion bytes of data created every day. 152,200 IoT devices connecting per minute. So you see that this is going to happen. The other thing is a lot of this sensor data, it's going to be for time series collections. That's why one of the reasons why MongoDB has moved into this market and kind of supported it. Okay, the connected home, home automation, the amount of money in this global smart home smart market. Okay, 126 billion in 2022, but 208 billion by 2026. So if you're looking for a new area that you might want to be interested in working, that might be one to take a look at, right? Along this way, okay, MongoDB's grown, right? So MongoDB is number 5 in DB Engine rankings, but the amount of growth that has happened. So this is just like by downloads alone. Tens of thousands of MongoDB downloads in 2014. But this year alone, 265 million already. So more people are downloading the community edition in 2022 and then the first 11 years of MongoDB combined. So why? Because people, the simplicity, they don't want to have 15 different database systems. Even though, polyglot persistence, you have what you need, you use the best tool. But general purpose makes the lives of the developers easier, the overhead less. But to be careful when you get into the cloud for that particular situation. Okay. The market grew 22.3% that. So it's not just all in the cloud either. You've got cloud databases that make up about 50%, but you have on-prem that is still growing, and even MongoDB expects it to be still 40% going forward. If you think about it, a lot of the healthcare and some of the banking and a lot of particular industries still want their things to be on-premise. Okay, so why do people choose it? Well, we talked about the factors and the features that are inherent to a document style database originally. Again, wanted by developers. They're used to it. They've been working with JSON. It handles a lot of different drivers, the Node.js driver, many drivers, right? They choose the databases. It's no longer like the developers choose the databases and the architects choose the database more than the DBAs or the data engineers. The growth is happening. So open source is super important. Lots of people are still using it. Cost consciousness is a reason for some of that. Percona is an open source database expert. Okay, Percona server for MongoDB is a full drop-in replacement. We'll have a lot of features that the enterprise version has. So I have a slide for that in a little bit, but I really want to get to the future. So PSMDB, well, Percona server for MongoDB. What's it made of? Underneath, it's made of the community edition. So we get to the upstream version and we tweak it, add a few things to it, but keep it fully compatible. Okay. So I have another slide later on, but this is the version that we're on, Percona server for MongoDB 6.02 -1, I believe that should be, not 11. So, but yes, it is 1, right? So, and here we also have the platter. So there's all the links. Again, you can see those in a bit. So what's the differentiation? Well, right here, there's the feature comparison. Percona memory engine, the WireTiger engine, all the encryption at rest, the full open source, the backup, all right, the LDAP, authorization, the auto locking, etc. So all those different things, there are some matches, a lot of matches. I really like doing presentations when I see people and when I can stand up. So it's much better than when sitting down. But that's fixable, at least that part. So now we're getting to the meat of it, what we really want to talk about today, the versions. Right? So version 6. Version 6 came out in July. It fixed a lot of the bugs that were in version 5, right, which last year's version. But it also became broken pretty quickly. 6.01 was released in August 19th. And then 6.02, which is the current version, was released September 28th. Now, if you go to the MongoDB community downloads page, it says 6.03 is the current. But if you go to the release notes, it still says upcoming. So I think it's about to come out for 6.03. There are a couple of interesting bugs that were there. All right. So we're talking about versions, but there's so many people out there that are still running older versions. 3.6 went bye-bye in April 30th of 2021. However, a significant portion of people are still out there, and people are trying to go through their upgrade cycles now. So 4.0 went bye-bye in April. 4.2 will go end of life in April of 2023, April 30th. And then 4.4 will go February 24th. And then we do an even quicker shift when 5.0 goes goodbye in 2020, in October. So even before a year, right? So MongoDB 6, which just came out, they're expecting it to go end of life there. But the important thing is 4.2, April 30th will be going end of life. So you need to make sure that we get your systems all upgraded. Now, I mentioned bugs. They did a lot of backports when they had 5.0. They backported and they broke a lot of 4.4 and 5.0. So keep that in mind and always go to the latest possible version of the major release that you have, right? Okay. So, okay, you're on version, 3.6. Well, you can't just skip. These are all major changes. And so you need to make sure that you go slow and steady, like the tortoise, not the hare. There's some special gotchas in between going from like version 3.6 to 4.0 that if you don't set your feature FCV correctly, you can run into some hairy things. Okay, so here it is again. That's just for you guys to have the link, right? And now we're going to include some of the biggest changes. So you heard, to be honest, you talked a little bit about some of the changes in the previous version. So I'm not going to go over many of those. Just going to kind of skip through there. The big ones, though, the big ones, I'm not sure if you mentioned this, but in 4.2, the auto splitter moved from the Mongo S, which is the query router. It moved to the primary on the MongoD. And what people found happening then was that they were having a lot more splits occur and a lot faster. So the write activity on their database was increasing. And if you're a write heavy application, then you could run into some issues there, right? It's interesting. These slides didn't stay hidden. So, okay. So 5.0 you see right here. This is the one. All right. So he mentioned the main ones: live resharding and the time series collections. Those are the main big things that happened in 5, and they were huge. Major rewrites to the internal engine occurred for both of these, for live resharding and for the adding time series collections. And that's probably why there were, a lot of bugs and a lot of things that had to be worked on. They also set the stage for versioning, the API versioning, which they've changed the name of, and they added multiple aggregations. So yes, 5.0, but now we're moving on up, right? We're moving on up all the way to 6. So here we are, version 6, okay? Many resharding and many time series collection fixes. They also added column store indexes, multiple new aggregation operators, some analytics, because they want to get further into search, further into analytics. And they also made sync improvements for initial sync and those type of catch-up. Another big thing that you need to think about and consider, the default chunk size changed from 64 to 128. So what that means to you is that if you are going along, then you're going to be able to insert more documents than before. And it's pretty much, my belief that they did this because of the aggressive chunk splitting that they'd had by the moves previously in previous versions, right? So if you have very active write situations and you've increased their chunk size, then you're going to get a lot more documents in there than you did before, which all makes sense. It also means that, you'll be balancing less, you'll be doing chunk migrations less frequently, that type of thing. But it's up to you based on your activity load and what your application's doing, whether that's helpful or not. You can still set this differently, right? So it's really going to depend on what you want to do and what your shard key is and how you've chosen it. Because I know that, to be honest, we've covered this, but you really still need to do your work up front and take care of your choosing the shard key. Because yes, you can change it, which we'll discuss in just a second. But if you do the work up front, if you know what your application is doing, and if you need to tweak it or change it or add a suffix to it or whatever along the way, that's great. But knowing it ahead of time and thinking about what you want to do when you select it the first time is a lot easier than going through all of the pain of trying to restart it later. Okay. So the main new features, the time series collections, the major improvements, and the fixes for all the customers, can now share. The time series collections in 5, you could not shard those, but those can be sharded in version 6. Queryable encryption is another huge one that was brought about. So in the past, when you encrypted, you had your data, your application sent it, you encrypted it in transit, it got encrypted at rest on disk, and then when someone needed to query that data, they'd go in, and the process was to decrypt the data, figure out what data you needed, bring it back, encrypt it during transit, and then any changes back and forth also had to be encrypted. Well, if you think about that for a second, that's going to cost you a lot of CPU and a lot of of network and a lot of traffic, right? But the CPU time that it would take, and then if you have to do any of the sorting, then that's another thing. But with queryable encryption, that allows you to leave the data encrypted while you query it. So you don't have to do the unencrypt and you don't have to do the re-encrypt. So it saves you two parts of that step right there. So this is a huge thing in terms of performance improvement. Okay. All right, so the other things that are coming into play, the aggregation operators. So I mentioned that MongoDB wants to do more and more and more of the search. Their database as a service offering, Atlas, they have the whole search, they have the data lake, etc. But they're building these things natively into the core engine as well by adding these new aggregators, right? So they're adding more and more functionality to the database. What you have to think about, though, for a second, is as you add more of these new features to the database, what generally happens? You're going to start seeing a little bit of bloat, the software bloat. So think back if you just really, really wanted a document store DB that was really fast, and that was all you really cared about. But now you've got all these other things that could be possibly slowing you down. I mentioned earlier about the change to the engine and where the writes were happening. So when the change was made to move the splitter process from the Mongo S to the primary on the MongoD, and then you have all those additional splits that were happening, and along with those additional splits, you also had all of the additional migrations. So that, and the migration, a chunk migration, is a cloning process. Okay, so you've got the original write, then you've got the splitting process, then you've got the cloning process, and then you've got the chunk move process. All of those writes were going on. So a lot of people with small, heavy write applications saw a significant performance impact between, say, 4.0 and 4.2. So when those change, or after that change made in between 4.4. So they added some parallelism factors, which helped reduce that along the way, and they've improved some of the balancing functions in the overall core engine. So that's improved some along the way. That's another reason why you want to go ahead and get further along up the stack there, if you would. So, but anyway, super important things. Another one, column store indexes. So if you think about MongoDB, if you think about their competitors, one of them is Cassandra. So Cassandra is actually faster than MongoDB if you have a fairly static schema, if you will, which MongoDB in the early days used to say, it's schemaless. You just throw it in there, don't worry about it. But I always said garbage in, garbage out. You have to also think about that. You have to think about how you're going to use your data. Because if you think about those kind of things, whether it's picking your shard key or designing your application or designing your schema, your tables, then you're going to have better performance, most likely. So anyway, so Cassandra has more of a set schema, and it's a column store. And with heavy write applications, it was actually significantly faster. But now MongoDB has come along, and they've added column store indexes. So, and that again, so the little checks here, right? So the green check, the new aggregation operators, this means that it is in the core server or core WireTiger engine parts, right? Which means the green checks do, which means that they are also included by default in the Percona server for MongoDB. Okay. The column store indexes as well. So there's a new feature called cluster to cluster sync, which means you can take your cluster, that it really was built for their Atlas or managed environments, but cluster to cluster sync, and you can just completely replicate it here. You can already do that by adding, a node and doing the initial sync and then catching it up and that type of thing. But this was done more immediately via the sync process at the file level, the data file level. So it's significantly faster. So there are some components, why you see a yellow check here. There are some components of that are in the core engine. So that's in the community edition. And then there's some that are not. Okay. So, and that's we're still kind of tweaking and working that out because version 6.0 immediately had a bug in it. And so we waited till 6.1, and then there were some bugs in that. So we just released Percona server for MongoDB a couple weeks ago. Okay. So So again, here are all the things, right? So you've got your time series collections, yes, in the core engine. The aggregation, yes, in the core engine. The column store, yes, in the core engine. The queryable encryption, yes and no. And then the cluster sync, yes and no. So these are the new features that we have. And then you've got, here are some of the operators. Now, this is kind of interesting. These are a lot of new operators. These are going to help the search. These are going to help the analytics, the real-time analytics. And a lot of these are also related to time series necessary things. You see down here, TS increment, TS second, right? But you also see here a lot of ins. All of these ins, first in, last in, or etc. Max in, min in. There are a lot of these ins. Be careful when you're using them because I've seen a lot of bugs in the versions, and all of the versions actually that have included them that are going on there. Okay. So always test first, right? But there's a lot of good things related to the analytics. So time series collections, I keep talking about them. They're a big thing. We remember earlier talked about all the different new types of data growth and where it's coming from. And a lot of that is the device data, right? Whether it's your mobile phone, whether it's your refrigerator, whether it's your lights, right? All those things. So you can turn on your lights before you can get home or make them turn blue, right? Or whatever it is that you actually want to do. You can do a lot of different things now. But the time series collection helped that. And then too, when you think about what are time series collections, right? Well, they're buckets of data. So this is really why you see the buckets there, right? So then it's weather pattern data, or it's wave data, okay? Or it's, seismograph, or it's also stock market information, okay? So it's a series of data points, and it's a sequence. It takes it about this much time. You space it over time, right? And then it's a sequence of discrete time data. Heights of the ocean tides, counts of sunspots, the closing value of the Dow Jones, etc. Or information from your nuclear power plant or your solar plant. So it depends on your outlook. So what are they used for? The big thing to do here, this is a bolt-on that they've done. This isn't something that they could just say, oh, I have this, right? They're building these functionalities. MongoDB is building the functionalities under the cover for these. So it's native, right? Buckets of data. Because you could do time series collection work with MongoDB before. You could use time to live into TTLs, time to live indexes, to get rid of the data after a certain point. But you had to code, if you wanted to use time series data, you had to code it and use it at your application level. Okay. So, but that's all not the case now. It's native, it's in there, buckets of data, and then you optimize it based on a timestamp, measuring the amount of change over time. So again, stock prices or cryptocurrency prices for trading algorithms. All of the metrics and monitoring for your host, because as the amount of data grows, so does the infrastructure to support it. And then think of your little Raspberry Pi, which sends information to the database. All these little things and systems, all of your sound sensors, just an amazing amount of sensor data that we have now, right? It's if you ever actually stop and think about that, if you were to visualize it, you would just probably see data points flying through the air all around us, right? So, okay. So again, why so important? Why does MongoDB feel the need to add this into their already fast, rapid, document DB? Well, here's why. TSDBs, time series databases, are the fastest growing database category. So database engines, DB engines, right? Over the last 24 months, and this was from the end of last year, but you see how much it's grown. So here's the document store. The key value is what Cassandra is, right? Your graph is your Neo4j. Your search is Elastic, Lucerne, those type of things. And then, of course, your relational databases here are flat, your oracles, although Postgres is doing a little bit of a kick up here. But the whole reason that the MongoDB has added this in and why it's so important is because of the data and the changes in the pattern and people and what we're doing. And so they want to be part of this market. And so here we go. We want to be a part of that. We want to get it. Okay. Again, why add all these new features? So your premier example of a time series database is Influx. And there's also Prometheus. Okay. So MongoDB wants to be the one stop, right? Your NoSQL general databases. And sometimes people like me and others might say, like the Oracle of the NoSQL world. So for a little while, not the current Oracle, the Oracle from X number of years ago. But it's also adding on, adding the whole idea of the developer data platform. It's not just a database, it's a platform, right? And that's a big change from databases over the years, where you just had the relational databases, and then you had the relational databases, a couple different ones, and then you had your relational database, and then you had your document database, then you had your key value, you had your Hadoop, etc. So you don't need the Hadoop anymore. Actually, you don't really hear much about Hadoop anymore, really. And one of the reasons why is because the improved ability to handle the analytics and the crunching of those large series amounts of numbers by these databases such as Redshift or Snowflake, some of these others, right? Databricks, some of these others. So the analytics, and then you add in the increased and improved search capabilities that Mongo has within it. And then you've got streaming events. MongoDB has change streams. So all these different things. I remember when you had to pay a totally separate license for Oracle's change streams. And you do for a lot of the change data capture type of things. So, but here's where you're going. Again, Postgres is also another database. It's not, doing the time series. It's a relational database, but it's added a lot of features, including a robust JSON type engine. Even Oracle has a JSON engine now. So, all right. So, talked about the new features, but here we have the changes. Again, you have to note the importance of the change size, 64 to 128. So it should address those more frequent chunks, and because of the prior changes. The resharding. So resharding, it's a very impactful thing. It's a wonderful thing because, even when you just had like 1 terabyte or even 500 gigs and you wanted to, reshard, you had to do it the manual way. So if you had a big enough development shop, you could start doing dual writes. You could go ahead and create your new collection and start doing dual writes, until you got to a certain point, and then you could do a cutover. But you don't have to do that anymore because MongoDB is doing it all under covers. So Deviant should cover the exact steps, but I'm going to talk a little bit about some of the problems that you run into. If you get stalled, if you run out of space, you're hosed, right? You're stalled. You're not going to, you need to make sure you address that size issues ahead of time. But there are also some bugs in there around stalling, around, missing or inconsistent or corrupted data, right? All these different things. So there have been improvements, there have been bug fixes, but the biggest thing is it's still a time and a resource thing. And, here's the reality, the impact and the cost. So yes, it's going to cost you more disk space. Disk is cheap, no problem. But it's also the double write. So it's not just going to cost you in terms of the writes, it's going to cost you in terms of impact to write ability. Because what's happening under the covers, you're cloning. All right, so you're going to have more I/O, which means more disk activity during this whole process. And then it's going to you end up utilizing more of your CPU. So you have to have more CPU. So between more disk and more CPU, then you're going to have money. And yes, you can auto scale up and you can auto scale down in the cloud environments and maybe even in your own private cloud, but that's actually not necessarily the point. So the things that you have to remember: do your work up front, pick a good shard key. If you don't, you have live resharding. It's not a magic pill, it's not a silver bullet. It's very helpful if you have, if you're paying a significant price because you have a bad shard key and you have grown very large without addressing it. So, but you also, the other thing, it's not always because you picked a bad shard key or someone picked a bad shard key, maybe someone before you did. It's not always because of that. A lot of times your business needs grow and change. Your application changes. So then you say, oh, well, we can get better performance if we do this, right? So live resharding, it's going to save downtime, right? And changing your business needs and behaviors. But there is a performance impact, so remember that. So, but if you have a really bad shard key, though, you're most likely seeing a performance impact already. Okay, so again, more CPU, right? Add more if you're over 80%, that's a good rule. More disk space, needs at least 20% more, so 1.2. IOPS, disk IO and IOPS. If you're over 50% currently used, add more, right? So larger data sets are obviously going to take longer to reshard. So that means you're going to see an extended period of impact. Okay. You want to make sure when you're resharding, you're using the same matching infrastructure. So a general rule of thumb, if you have decent disk speed and decent IOPS and throughput, etc., then you can see 10 gig in 6 minutes and 50 gig in 13 minutes, which is pretty good jumps right there. And that's because of the parallelism that you're talking about. So it's going to impact your MongoDB performance. Your MongoDBs are your data-bearing nodes. So and if you're having to actually do a lot of rebalancing and chunk moving and splitting during that time as well, then it can also impact your MongoS, which are your query routers, and they're also going to be your data gatherers and your sorter. So that means you're going to be using more memory. Okay. The other thing about it that's super important to remember is during the process, during the last 2 minutes of the restart process, it creates an exclusive log. And if something has gone wrong along the way and there's been a stall, it's going to hold that exclusive log longer. So key things to remember. All right. So the cluster to cluster sync. Remember, that's another great factor, another great feature, right, that you have available. Some functions are still, that's why they have the yellow check earlier. Some of the functions are still available to the core community function. And so there's a Mongo sync binary process, okay, and that's involved with the cluster sync. They help migrate the data from one cluster to another, so and keep them. So now, when you're doing these syncs, you have to use the commit command on the destination cluster before it converts the indexes and finalizes the changes. But during that commit process, your writes are blocked again. So the larger your collection that you're working on, the bigger impact that you will see. The more write heavy your application is, the larger impact you will see. So, kind of common sense there for that. But the writes are going to be blocked on your destination cluster until the sync process gets through the index validation or starts that index validation, which is the last one of the last steps there. It's not the last because you've got to say, okay, I'm done. Okay. So what have we talked about? Well, we've added all these new features and want to complete developer data platform, not just the database, not just a document store database, but we've got the time series in there, right? And we've got a lot more of the aggregation and the operators. We've also got more search capabilities. So all these different things, right? But we're also here to help if you need any assistance with that, because we've got an app for that. So Sergey showed you a little bit about, PMM, a little bit of a demo, but that was a beta version, right? We have our latest version of PMM, Percona Monitoring Management. I know they're very interesting, names, but PMM is pretty good. So PMM version 2.32, in there, in PMM 3.2, we've added for MongoDB, we've added multiple new collectors, metrics gatherers. And in order to utilize those, you will need to enable all the collectors. There's some default settings on there, but you'll need to take a look and see which connectors you want to utilize for that, so you can do. So there's a demo. But I need to add a new database for Mongo to that particular thing. But you can obviously download it as well and start taking a look at that. But Percona version 2.32, we've also, so our Percona backup for Mongo, which I don't have anything to show you about that one, but it's integrated tightly with PMM with the changes, and the changes in there, you're allowed to do some up there. So here's where you can find the PMM info, okay? Release notes, and here's where you can find the actual docs. And on the previous page is where you can find the link to itself. But here's a quick little dive into it. here's what the environment looks like. Okay, so you've got your server, you've got your client, and here are the exporters that I talked about. You've got them for Mongo, you've got them for Postgres, and all these other ones. All right, so you get your agent, and you're going to send all the information. And within the PMM server, you see how it's fun, right? It's got the ClickHouse engine for query analytics, and then it's got Grafana, and then it's got Victoria metrics for all the time series type things. And then you also have a Postgres. So, and this is kind of this is a summary of a replica set. And these are some dashboards that are in play. We're working on some new ones, but you'll see here, it gives you, this is currently showing the config server. And it shows you which the versions are, and it also shows you what its service name is over here, right? And secondary, primary, okay? What is PMM? Well, you use it for monitoring, right? But you can also, this is experimental dashboard. You can also get some information similar to what you find in an ops manager, such as your hottest collections. This is by reads and or hottest collection by writes. Okay. And then if you wanted to see that in a graphical bar format, here you can do that as well. And all these dashboards are user adjustable. They're basically JSON scripts. So you can change them out. You can create your own dashboards at will. So there are lots of different things you do there. Okay. And then if you want to dig deeper into the collection details, here you're going to get your largest collections, okay, and the size. Okay, so this is by the number, not the size. You have 1,000, right? And this is just a small little one, obviously. But your database, your collection, right? And then out here by the size. Okay. And then column stats, you get your details, right? Which is also over here, you're going to get your mean and your max, right? Your information about the collection. If you pop this one down in collection activity, you get more information there. So there are a lot more things on this dashboard. These are just the ones that fit on the screenshot. So lots of metrics to play with there. So don't be afraid. All right. And then oplog details. How long is it till you're going to fall off the oplog? Don't want to fall off the oplog, especially if you're up in the terabyte range. Once had a customer that was, I think, and this was several years ago, but they were 24 terabyte, and they were doing some massive aggregations, and their secondaries fell off the oplog, which means then they needed to do an initial resync, right? To get, and you have to do an initial sync off of your primary for 2 secondaries, which is going to add to your write load, and both of your secondaries are significantly behind. That's a dangerous situation to be in. That's kind of like people who run production and they run a primary, a secondary, and an arbiter. If you're doing that, you do meet your quorum. But one of the problems that you have with that, if something does happen to your primary and you fail over to your secondary, while you're fixing the old primary, now secondary, you only have your primary. So you've actually killed your redundancy and your HA ability there. Right. So that's something to always kind of remember. Is people think, I can just put a small tiny arbiter process and save money on the server. But really need to think about what the cost of doing that might be if something were to go wrong. So free tips along the way, not just talking about the new features. So then just a couple other nuggets, right? Top problems for things that are going on. Here are the things that we see for our support recommendation organizations primarily. Upgrade, performance problems, tuning, indexing, issues with scaling up, and then configuration issues. If you don't fix the hardware, set up the hardware correctly underneath, or the OS correctly underneath, then you're probably going to run into problems. Things such as like the read ahead, all these different things, and transparent use pages, et cetera, et cetera. So how do you fix these? You follow the upgrade steps. You make sure you don't jump. You never turn off the balancer if you're in a sharded cluster and you're high write. Some people like to turn off the balancer because they're starting to see a performance impact because they may have too short a balance window or something's going on, or maybe they're not fully dressed out and spec'd out the way they should be. But if you turn off the balancer and you're behind, so that's why you turn it off, then you turn it off, and then you're going to end up getting more behind and have more chunks, and then you're going to end up with unbalanced shards, right? And then if you keep turning the balancer off or you keep it off, you'll eventually get to the point where it's actually unrecoverable in its current situation. And then you'll end up having to take downtime anyway. So it's better to find the balancing window that works for your application, whether it's late at night or whether it's, for 2 hours of the day or 3 hours a day. It really depends on how many chunks you're creating. Anyway, so fix the things as you go along, right? If you need help, we're here. Professional services, managed services, etc. If you are sharding, shard early, because one of the things, if you get to 80-85% disk capacity on a sharded cluster, and you need to add a shard, just remember it's also a cloning activity that's happening while you're moving the chunks and balancing out. So you have 2 80% shards, full shards. You add another shard, which again is a replica set, so it's 3, right? It's going to take some time for that to balance out so that you have a third. And in the meantime, you can see some performance degradation. So keep that in mind, right? Shard before you absolutely have to. Don't wait till the last minute. It takes time for the balance to the chunks to split and then for them to balance. And then make sure that you take care of your hardware and your OS, your system, and or any architectural advice along the way. Okay. All right, architectural advice, talking about that. Here we go. So some general things. Obviously, these are, more people know this now than used to, but use different data centers, use different availability zones, your regions for your replica members. Basically, don't put all your eggs in one basket. Okay. Use the right level of server. Make sure you have plenty of CPU, RAM. You have plenty of IOPS. You can get some of the lower, level servers, but if your network can't keep up with the traffic that you need, then you're probably going to have some troubles and issues there. So if you tend to run a geographically diverse or dispersed application or instance or cluster set, remember that there are a couple of read preferences that you can utilize. You can do the nearest. Okay. You can reduce latency by doing nearest. You can do secondary read preferred for heavy. You can add additional nodes that you use strictly for analytics or for batch processing and for aggregations. Okay. So there are many, many different things that you can architect and help along the way. You can add hidden nodes so that you can do your backups, take your backups off with. So all kinds of things that can be done. Okay. So I think that pretty much is going to take us to where we are. Again, here are the downloads, 6021. Okay. And there's this. Okay. So if you have any questions, feel free to reach out and let us know.